how many of you are speakers here? Can you raise a hand? And who likes the part where you need to wait for your time to present? Yeah. Okay. So let's start.
The mic. The mic does it.
Okay. Yeah. 1, 2. Do you hear me? Okay. So just before the microphone, I told that I really hate the time when you're just waiting for your presentation time, and so I made some timer for it. And okay, let's go to the real presentation. And I'm Aurelijus Banelis. I'm a software developer from a company called NFQ, and today I'm going to talk about real-time first metrics. For those who are new to the term real-time first metrics, I will use example from, guess what, lunch. And as I'm a software developer, I always try to search for some improvements in every environment. And in this environment, I saw that there's a problem with thermoses, because if we have a big queue and waiting to get to the end of it, and when we finally reach the thermos, we saw that it's empty. And it's kind of a problem, and I think it can be improved. And luckily, on the other arm, there's another type of thermos that has some kind of metric that shows how much it left, so you can choose the better queue and don't waste your time, especially if you're preparing for the presentation. So that is the example of real-time metrics in the real world. But of course, we are in BuildStuff, which is software conference, and today I'm not going to talk about the food. I'm going to talk about software development. And in particular, I will going to present 3 parts. One part will be introduction water metrics. Another part will be comparison for the real-time metrics and delayed metrics. So there's no silver bullet for everything. So you should understand both advantages and disadvantages. And I also like demos, because every good presentation should have a demo. Okay, so let's start from the first part, what are metrics? And I give you a copy-paste from Wikipedia what is metrics, but it's not fun. So I thought it would be better to use a personal example. And what I was doing, I was writing a script to download from AWS Glacier. It is very cheap storage for big files, but it doesn't have a very good UI to download files. Probably it's the marketing reason. And it was doing the 2 simple things, just signing the request and then downloading the file. And for the small files, it was working very fine, but when I try to download some bigger video, I get this connection reset by peer error. So what we developers usually do when we get the error message, we usually go to Stack Overflow and check what we should do. And they said that you should use some buffer and store some packets in memory. So there could be a problem that the network speed and writing to disk is different. So we can do Stack Overflow driven development, but if we're more serious, then we should take all information as a hypothesis and then test it ourselves. So I remembered what are real-time metrics, and that net data is one of them. So I did exactly that. I checked what are the network traffic and what are writing to disk while I was running my application. And I tried different values for the buffer, so I could really understand what is going on, and if I raise the value, what are the memory consumption and how it affects the network traffic and writing to disk, and if I lower it. So this is a basic example how you can better understand your software even without changing a line of code, and of course you can make a more calculated decision, not like just use 1 gigabyte, just use 20 kilobytes, etc. And now you can think that, yeah, it's a kind of simple application, simple example, but what we are in a conference like BuildStuff, and everybody wants to build a very scalable software. So what real-time metrics has to do with big software? And for my opinion, it is the easiest way to go to the data-driven development area as compared to other ways when we want to work with big data or need to solve some consistency problem. So from my opinion, if you if you're having a little project or you want to just test the technology, going from the real-time metrics is the way to start. So that is about the introduction and what are metrics. So now you should have a simple understanding what are metrics and what they can do. And now when I propose that the real-time metrics are a good thing, it's time to compare it in some real use cases. So I will be talking about two subtopics. It's decision making and debugging. And to illustrate those, I will use three tools. One is NetData. Basically, it's a real-time monitoring tool, and it is intended to be used on one instance. As opposite, Elasticsearch is a database, and it can be installed on one instance, but in practice it's usually installed in a cluster. And finally, the CloudWatch is the proprietary tool for Amazon Cloud. And if you're not familiar with Amazon Cloud, there's Google Cloud Monitoring or some Azure application inspector or something like that. So every cloud has something similar. And CloudWatch is the example where you want to work with hundreds, thousands instances, and it could scale as the cloud scales. So let's start from decision making, and as every programmers do, let's start from the problem. So I want to tell a story from a real story from my personal experience. My team was doing some big database migration, and when Percona tool said that yeah, migration is finished, we checked the service looks still working, and there was a final check to see if there are difference between the old data and new data, because we have different sources and some converters in between. And then when we checked, it was, whoa, there are more and more errors coming, and that means that we should roll back or what to do. And then a colleague told it very calmly and very simply, look, there's out of sync MySQL slave cluster, and you're checking it with a slave, so it's okay, you don't need to roll back. And then you're in a kind of situation that what? I'm doing the deployment and there is some data that can make my big decision wrong. And this is just one example. There are plenty more of them when you are doing some debugging, some big debugging or deployment, and you think that you can trust the data that's are presented to you. And one of the my favorite example is with Kibana. When on one tab you see that data, on another tab you don't see them. And the reason was that because of some URL, there was a JavaScript error and not all data was presented. So you never know that it's true. Also, there was another problem when the Amazon Lambda was used to push logs from CloudWatch to Elasticsearch, and then Elasticsearch had a capacity limit of 50, and because there were too many messages, it just started dropping the packets. And when you are testing some big infrastructure and you saw that there are no new messages, you can think that, hey, something wrong. I am testing it again and again, it's still not working, but after a minute or 10, you just receive all the message because of retrying. It takes a lot of longer. And the final example is just in BuildStuff we heard a lot of talk about serverless, about Lambda functions and all that fun technologies. And when you execute a Lambda function, you want to see what's really happened. And when you're refreshing the CloudWatch logs, you can get the first message, and then you refresh. Okay, now the final log message is received. So it's kind of, you need to have understanding that all data that you get can be wrong, and it feels wrong, especially if you're doing some debugging a lot of time, or you're doing some very impactful stuff like deploying. And then during those situations, you want to have some tools or some infrastructure to just check what is really going on. And then I found NetData, and it has two benefits. First of all, it is closest to the source as possible, because it is installed on the actual machine, so you can just SSH to it and have some port forwarding to see the dashboard, and it looks something like this. So if there is some error, you can get the insight instantly and understand what's really going on. And the good thing is that you can combine different monitoring tools. For example, you can have both CloudWatch, Elasticsearch, NetData, or Datadog, whatever you like. So just having the opportunity to check the real data is one advantage, but we are humans, and just watching the logs are fun, but not very useful. The usefulness as a software developer is to make computers watch them and to adapt and do some scripts or some stuff according to them. And one of the example how NetData default implementation can help you is by alerts. And one of the default alerts I found was when I was uploading some video, big video to my server. I got the alert that, hey, if you will still be uploading, writing to disk in this rate, after 6 hours it will be full. So this is a good way then that you can get the notifications that you're probably doing something wrong and you should act on it. And instead, if we compare the CloudWatch, only a few months ago there was no high precision metrics. So for example, if you had error, you need to wait for 1 minute or 5 minutes for the alarm to change from OK to alarm and to trigger some Lambda or auto-scaling or etc. So that was kind of odd. And many teams was implementing some custom solutions. For example, instead of Elastic Load Balancer, which is Amazon solution, they were implementing some Nginx process just to get the error faster and do the alerting manually. So NetData is one of the examples when you can put all the alerting as close to the source as possible. So there was two benefits of using NetData or the real-time metrics, but of course it is not a silver bullet, and there are some disadvantages. And I will talk about two trade-offs. The first one is you can lose the data, because for real-time metrics to work, they usually store everything into random access memory and not storing it to hard drive or any other more reliable source. You can see the example from CloudWatch. It is not very visible, but the idea is that there is traffic for one instance, and there's some point where the health check fails, and the CloudWatch just informs of the scaling group to kill one machine and to set up another machine. So it's very good to have some other monitoring infrastructure on top of real-time metrics, because usually real-time metrics works only at the instance level, but not when you have a cluster or some bigger structure. And another thing that real-time metrics cannot give you are relation and aggregation from different sources. And one of the classical examples is deploying a new version. If you have a bigger project, you probably want to have one application per instance, or if you want to test if giving more resource will give better performance. So you want to compare not the applications in the instance, but the actual instances. So there is an example from deploying new version. So you can check different metrics and visualize it in a better way than the data can do. So that's about the decision making. Just a quick reminder, Nedata was the good tool if you wanted to get as close to the source data as possible, get to more realistic, despite appearing about some errors aggregating them, and Elasticsearch for aggregation, and relation, and CloudWatch if you have a bigger infrastructure. Okay, so let's go to the second part. It's about debugging, and this part is most important, at least I think that. So also let's start from the problem statement. These days we have a lot of tools to debug things, and a lot of modern tools to debug. And if I say some debugging tool, you probably will think about IntelliJ, Visual Studio, or another IDE. And you probably are used to some step-by-step debugging when you can stop the application, check the variables, inspect the elements, and in that way understand where are the problems. But it works very well when you're doing some initial development or unit testing, but we all push some programs to production, and I'm talking about web application mainly, and when you get 10 or 20 requests per second, you will get something like this, and or yes, of course you can do highlighting or filtering, but you still have too much information, and it's very hard to understand it. And at that point, you think that it can be worse than that, but it can, and you can be dealing with asynchronous code as well. So even with a lot of logs and a lot of information going on, there are some external services, database calls, etc. that can be asynchronous, and that can make your debugging in production a nightmare. So I came to this conference and prepared this presentation mainly for one proposal, and that proposal is to use monitoring tools in your development environment. So you can get familiar with how it could look in the production. So if we, as a developers, are using the step-by-step debugging tool, so we are comfortable with that. But when we actually push something to production, we are very hard in understanding what's really going on. One more advantage for it is that if you are running those monitoring tools on acceptance test or load test, you can understand how your application should behave when it goes to production. And if you can understand, then you can add some additional metrics and know the baseline. So it's and the current infrastructure allows you to have all these tools in your local machine without big configuration or a lot of code, additional code. So I will show it in the demo. And yeah, that is my proposal, to use development, use monitoring tools such as NetData in development environment, but also just using them, you cannot test all the cases. And some of the interesting cases, edge cases, are with the network. It's very hard to predict that some parts of the network can fail or took longer than you expect. And for those who were in the keynote yesterday about chaos engineering, you should be more familiar with the problem. And here you see the example how we debugged the issue for the latency in MySQL database. So before reaching this graph, there was some logs that clients responded with timeout error from the service. But when you check the application logs, everything is green, everything okay. And there was slightly bigger response times, only one availability zone. So that means if you have a data center, it has 3 parts. So if one is down, the others can still be alive. And only in one availability zone there was bigger spike. And probably the case is that a DNS or some network issue was, so it took longer and clients had a timeout. So when we have such a problem, we also can say, hey, it's a good graphic, only one per, I don't know, month or year, so it's good. But the thing about the main idea behind looking at the graph is to make a decision. So if we cannot eliminate that problem, we need to adapt our code. And how many of you have services with increase or decrease functionality? Yeah. And then one of the solutions for that problem was to introduce retrying. And if you have functionality with increase and decrease and you retry it, then your application data is invalid. So to do that, we needed to adapt both the client and the service. So we send the final value, not the action to increase or not the action to decrease. So same request can be repeated and will not corrupt data. And by doing that, we can mitigate some errors like this. And another interesting example is when you have a lot of instances, there's, I can even have a laser. Okay, so here there's some spikes, but everything looks normal, and then the suspicious part is here. And something about this time, there was a lot of error from the call lines. And flat line usually means that you reach some limitations of some software, network, or proxy, etc. And what is good about having monitoring is that you can have the overview, and then you can dig down and see what's there. And when the network traffic of each interface was displayed as a stack, so you can see that there's about the same amount for the blue and yellow or something like that instances, but for the green one there's not enough traffic, so errors were in from the green instance. And the problem was that there was an image generating service, and there was a proxy that redirected everything to the internet. And the instance of the proxy was lower, not resourceful enough as the instances at generating the images, the network traffic, so you could see the flat line here. And this also gives the example in the answer if you wonder, can we just log everything and push to the network, to the centralized service, so you will get something like this, because you can just make your network full and no good request will get passed through it. So my point is that you should understand that there are different ways of monitoring, and you cannot test everything locally. So that's about the debugging, and as I mentioned, this is the most important part. If you will get anything from this presentation, so go home and try some real-time monitoring tool on your development environment. Try sending some custom metrics and see those while you're still in development environment, so it will be easier to fix bugs in production environment. Okay, so enough of the static slides. Let's go for some demo. And yeah, you could see in the background there was a real application going on, and actually there was this application. It's NetData, and basically when you install the NetData on your machine, you could see something like that. A lot of metrics, for example, the basic ones are CPU, memory, or disk. But what I really like about NetData is that you not only get the aggregated metrics, and to be honest, I don't understand most of the metrics, but that's the point when you get a problem and you can understand it with the tools you have, you just learn more. So when I have see some problems, so I can filter it by the containers and to see how each container is doing separately. So it's very easy if you are doing some load testing or your system consists of as we like to call microservices. And the same thing that you can do in your local environment, you can also do on production. Of course, by default, it is binded to all ports, but for security, it's better to have on the local host. But just for the demo, I'm using Nginx proxy that, yeah, you can try this URL, it's password protected. So yeah, so if we see the container for the web, and we're scrolling some elements, you can see that there is write memory spike here. So NetData is one of the tools that can monitor itself and not crash. Try to do this with Elasticsearch or other append on the database. And so what is interesting is that when you go to some aggregated metrics such as this, and you see that there's some strange things going on, and you can go to some custom metrics here and see some similar ones. So I just pushing the NetData has a full support for StatsD protocol, so the application can just push metrics using StatsD protocol to NetData, and you can see those here. And what are those doing? Make it a little bit bigger. What are those doing? Are pushing aggregated metrics to CloudWatch. So if my instance will go down, so I could at least have some sort of metrics to understand the cause. And those metrics are pushing to CloudWatch, and I will not hit refresh button before showing this because the hotel Wi-Fi is SML conference very good. Okay, so by default, Amazon gives you basic metrics about the network, about the CPU, about the writing to disk, but by default it does not give any metrics about memory usage and disk space, because that's the way virtualization works. So I am pushing those, and it's a real site. And yeah, usually, yeah, so it's real. Okay, so another interesting thing is you can see that it is real time, but what I really like when I go to some container, I can have isolated version of what's happening here. For example, if you would want to download slides for this presentation, you could go to my page and click on the slides, and you can actually see that there is spike in usage. So that's the way you can understand if somebody is DDoSing your service or what's going on. This is just a basic metrics, but you can also add many custom ones, and that way when you are in production environment, you can feel the same way as in local environment and understand what's happening or what's happening there. So yeah, and another interesting idea is that if you have some error or some alarms, I think there's one alarm on my local machine that says that I'm running out of disk space. So if you have some error on your production environment, NetData has a REST API, and you can export all the metrics here, so and send to some safer place, for example S3 or other backup server. So when for example, you have an error in the middle of the night that something goes wrong, so there's a UI to export all the metrics, but you can program it using REST API, because basically it just calls the REST API, and then put everything, so you can put everything in a safe storage, and then in the morning you can just check what's happening and get all the details and understand the problem easier. So I still have, I think, some time. So in the description I told that there will be some exotic ways to monitor them, and I already told that there was some script that was pushing metrics to CloudWatch, and because of the slow internet connection, it is pushing it very slowly. And one of the interesting things is that it's not a simple bash script, but but it is distributed graph shell, and that means that there's a bash fork that supports running programs in parallel and making them not that painful. And to show that, yeah, and just quitting the vim. You can also just will check out. So it can also generate the dot file. That's basically the graph explaining what your program is doing, and so it's easy to tell the colleague what's going on, and because you have that graph explaining everything what's going asynchronously. So what we are doing, we have a curl request to the NetData, then some jQuery parsing to get only the data part, not the metadata. Then T command is something from the bash that copies data to multiple receivers, and then we can do some calculation separate in parallel for free memory, for the used memory, for the cached one. Calculate some statistics, for example, minimum, maximum, average, or count of the elements. Paste command is also from the bash, which just blocks until all the streams finishes. Some ADK magic just to format the text, and the final command is sh. So this is maybe not the most stable tool to work in production, but it gives a very interesting idea about the running elements in parallel and using the file descriptors instead of HTTP requests, because you have one step lower, and you can, if you want to reuse multiple programs, you can reuse them still in the file descriptor level, which means you're still only hitting the kernel. Okay, so when you understand what it's supposed to do, we can check what's really going on. And as you saw there in the production environment, there was those lines here. So those are generated using the statsd protocol, and what it does, it just sends the string like this, and using TTP protocol to localhost, and that's the default data port. And there's, because this is actual working script, not the hello world example, so there are some functions on top of it, and you can see that there are our color request, that there are GQ, there are splitting, and the new thing that you can learn today, because BuildStuff is what programming language can you speak, so now you can speak the distributed graph shell, because it's basically a bash, and there's this line that makes making the commands to get information in parallel, because bash has one curly bracket, and there's added to this format two curly brackets. Okay, so let's change something. What do you think? Because it's demo. Okay, so to understand, when I am debugging, I not usually use the shell script as the end one, but I usually use some cat, and because there is a lot of text, I will just add a new line to do it. And now and now if I run the script again, you can see that this script is calling this command, and basically it's AWS command line interface that pushed to a cloud, that pushed to metric to CloudWatch using some names, and those are the calculated values from the JQ command. And the main idea I want to tell you, I still have some time, is that if you are using monitoring, it's better to have different layers of aggregation. For example, the most detailed data in your instance as per second precision, and then if you go up, you can aggregate it. For example, give the maximum, minimum, and some values to CloudWatch, and on top you can do some health checks. So it will be easier just to see that is there error, where can I search it, and then analyze it in detail. Okay, and probably still have a few minutes before the questions. If somebody wants to have a question now, I can answer. If not, I can show more demos. Yeah.
Can you also use net data, for example, to monitor the Docker-based environment?
If I understood it correctly, basically, I'm using net data outside of Docker environment because I want to monitor the Docker environment itself. But well, as you saw from the example, it is reachable from Nginx, so I just can give the IP address that is visible from the Docker. I can mount the Unix port, etc. You can also do it inside the Docker, but I don't see any need. Okay, so last exotic thing I want to show you is what I have here. I saw that we can add some custom metrics to the application, and it can be done using STD protocol. And if you have any application, this is the real one. I just didn't had hello world application because it will be the second example. So usually what you do, you just search for some plugin for your language. It's a Go language, and then do some initialization and then add the parameters so you can get the information. So it's very specific to your programming language, but it's not a rocket science to add monitoring. And now you can say that does that mean that I should rewrite all my legacy code and add monitoring? Well, the answer could be yes, because you can understand what's really going on. But another exotic solution is to, instead of changing the code itself, you can change wrapper around that program. And for example, if we go to the Rust, what I did, you can see the very simple application. This is more like a hello world. So it just brings some simple output, and then it uses not only the standard output, but also the standard error. Because every application these days and every programming language can have access to standard output and standard error. And if you are pushing some metrics to standard error or some error messages, other applications can interact with it. And if I show you the demo, I think it's free, you can see that there's output as a simple output, and then the monitoring tool receives those different file descriptor information and push those as a metric. So if we go here and we will check the statsd section, and it counters just press the thing, refresh, yeah, we see those events. So you cannot believe that those are the ones actually happened. So let's make them again, and you can see those events happen. So that's the way when you have some application, that application using some logs to standard error, standard output, you can just switch them and add the wrapper. So what it really does, it uses some bash magic, which is named process substitution. And another fancy name, which just says that these symbols means that instead of using the file, you can redirect the output to your application. And I'm using the Rust because it's still low level, but better than C. And this sign means that you're using the second file descriptor or the standard error. It is easier to understand the bash if we're using something like app.php like this. We can see because usually the dash shows both the standard output and standard error. And if we redirect standard inputs to nowhere, meaning device called null, we can see only the error messages, and we can also redirect on error messages and see only standard output. So it's a basic usage of file descriptors, and by doing that you can wrap around your old application. And yeah, I think my time is going out. Any more questions, or I will continue with the demo? And I think there says no Wi-Fi connection on slid, but yeah, probably there's no questions also here. Okay, so anybody know Rust? Okay, so we'll be careful. Okay, so let's see what is doing. So we go to Rust, and it should be some SNC and main Rust, and there is some highlighting. Okay, so there's nothing special about this application. There's a lot of code, but I will just say the main things about it. So yes, probably everybody understands to okay, just to make it bigger. You just run the program and then start reading lines. And the main thing here is that you're blocking on the input-output, so you can actually do it in parallel. So your producer application is not blocked by the monitoring application. And there is just creating new string and then reading each line. And then if there's no error from reading it, and it's not the last one, we just call the monitoring library. Rust also have a library for monitoring, which is just the statsd client here. And yeah, the initialization of the monitoring light, just to show that I'm using the localhost and default port. Okay, so that's the main caveat here, is only that you're reading by line. In that way, you get one line and you instantly produce it, the matter monitoring. Yeah, and it can be strange when using the increase and decrease. And in fact, by definition, in statsd, if you put the increase, it shows the last value. And if you want to see the spike, which is easier to track, because there's just an event, not some value increasing all the time. So I just use the increase and decrease. Okay, so that's probably about it, about the demo. Just a quick, yeah, reminder what we showed and what I haven't showed. And if you're not sleeping and no questions, I will use my last minutes to show the last tool I used in presentation. It's Kibana. And before using that data, I was pushing some logs and metrics to the file, and then because Kibana is using Elasticsearch as a backend, as a database, and all databases needs a lot of memory to run properly, so I didn't want to put it on the server, so I running it locally. And the wrong thing about using Kibana instead of real-time metrics is that you usually push the logs and forget it, and then you really need it. When the time comes when you really need to debug, you realize that not all the data is correct. For example, this is supposed to be the response time, and we see that sometimes it's negative. So I want to say that you should start using real-time metrics, so you will get all the wrong data instantly, and will not. If you are pushing a lot of logs and not using them, so there's a big chance, like you see before that, there are some bad data stored, and you're paying for that data. Okay, so very quick summary. Before I started using all the metrics, it was the kind of different mindset where you just write the code and write unit tests, it works, it's okay. But when I try to use metrics and try to base my decisions on metrics, then it's become the different mindset. For example, if there are two colleagues arguing, let's use Rust analysis, says that let's use Go, and then the project manager can say, so add two metrics, so let's compare it, let's test it, and make it the data-driven, not like my opinion versus your opinion. It's about testing. So my suggestion to you is get this monitoring like a mindset, and current ecosystem allows to have real-time metrics right in your application, right in your server, and it doesn't kill your performance. So thank you, and time for questions if we have time.